I am so done with science videos, okay? They make me do 4 whole videos that take 10,000 hours to edit. I'm just so done. I'm so angry. I just need to take my anger out on something. Ah! Ah! Ah!
Hadouken! Perfect.
Boy, do I feel better, but I still need a topic to talk about that's completely unrelated to science. How about math? And you know what my favorite kind of math is? That's right, as you guessed it, AP Calculus BC FRQs. But wait, we're gonna need some help if we're gonna finish this FRQ. I have just the person. Hello, Mr. Ematics, we need your help.
Good evening, everybody. My name is Dr. Rojeshwari Ematics. Very happy that you came to tune into the video presentation. But regardless, let us get into the problem. So today, Dr. Math actually gave us a very decent FRQ question to work out. Not the simplest, for the stupid people, but if you really pay attention in Miss Dennis Stifler's class, you will very much have an idea of what to do. So anyways, we have this series 1 over 5 to the n minus 1. Now, very much, we have to use we basically have to use the question part A actually says, determine if the series converges or diverges and explain using complete sentences. Very much happy that we did that. Okay. So the basic premise of this problem is that we have a sub n, which is our original expression for a series, and then we have b sub n, which is a simplified version or simple version. Very happy that we have this simple problem right here. But anyways, we shall take limit of n approaches infinity of a sub n over b sub n. Now that is basically saying this complex function divided by this one. Okay, complex expression, not function, expression. So then we take 1 over 5 to the n minus 1, divide that by the other fraction 1 over 5 to the n. Then we shall arrive at 5 to the n over 5 to the n minus 1. Take the limit as n approaches infinity, of course. Very nice, very happy that the problem is as simple as it is. Then we take another limit, but this time we divide each term by this 5 over n. Now, why is this, Baya? Why is this? So that we can actually approach a value that is not equal to 0, because right here, if we were to do this, we would not get the value that we want. We would not get a finite value to show the convergence or divergence. We would not arrive at that value. So when we divide each term by 5 to the nth power, we get this expression. Then we simplify and we get 1 over 1 minus 1 over 5 to the n. Then we take limit again we take limit. Okay, but this time we should actually cross this limit out. This should not be here, but then we move over and we get 1 over 1 minus 1 over infinity. This value right here, we can see it equals this value, which is 0. Baya, 1 minus 0 is equal to 1. So we get the expression 1 over 1, which is equal to 1, which is greater than 0. So by this one, we can then determine the fact of the matter that the series indeed converges, and we can see this very clearly by the steps that I took right here. Very nice, very happy that you all understand. So in part A, we finally figured out that this series converges. So in part B, it is asking us to find the finite value at which the series converges. Now we can basically get this in the form of a times r to the n by factoring out a 1, which isn't really doing much, but that will serve as our a. And then r becomes 1 over 5 to the nth power. Now you can do this because 1 raised to the nth power, n can be infinity. 1 times 1 times 1, how many ever times you do 1 times 1, it's still going to be 1, So we can just basically make r this 1/5 value. Now when we do a bit of simple calculations, we do 1 over 1 minus 1/5, we get 1 over 4/5, and then we do the 1 over, so that is the reciprocal, no, we get 5/4. That is the converging value. So in part A, we finally figured out that this series converges. So in part B, it is asking us to find the finite value at which the series converges. Now we can basically get this in the form of a times r to the n by factoring out a 1, which isn't really doing much, but that will serve as our a, and then r becomes 1 over 5 to the nth power. Now you can do this because 1 raised to the nth power, n can be infinity. 1 times 1 times 1, how many ever times you do 1 times 1, it's still going to be 1, you know. So we can just basically make r this 1/5 value. Now when we do a bit of simple calculations, we do 1 over 1 minus 1/5, we get 1 over 4/5, and then we do the 1 over, so that is the reciprocal, no, we get 5/4. That is the converging value. Continuing on with part C of the FRQ, we have the series, the summation of 1 over n squared minus 1, where n is equal to 1 on the bottom, and we have the infinity. So now what this question is saying is rewrite the series as a sum of partial fractions and simplify it completely. Okay, so what do we need to do? So we have to separate this into its component parts. So when we factor the bottom, we get a n minus 1 and we get n plus 1. This is a difference of squares. Very simple factoring. So what we do is we got to multiply this whole expression out, this equation actually out, we have to multiply it by the n squared minus 1. So we get the 1 equals to a times n plus 1 plus b times n minus 1. So we gotta let the n is equal to negative 1. Then we do this right here, and then we get b is equal to negative 1/2. Very simple, very easy equation to solve right there. Now we gotta do the same thing right here. What value can we put right here to make sure that the b is multiplied by 0, so we can isolate the a as our only variable in the equation? To solve for it, we have to make the n is equal to 1. So we do the 1 equals a times 2 plus b times 0, and then we get the a is equal to 1/2. Now when we put this back into the equation, sorry, this is water stain actually, it bled to the paper, but we do the 1 over n squared minus 1 is equal to this expression right here. What we can do then is we can carry the 2 down to the bottom, and we can take this negative and plop it out in front, and then we can rewrite the series as this beautiful telescoping series, which then they could ask you, find the finite series, like the finite value, like, in which case you would just do the formula as given, but that is for another day.
And for the last section of this FRQ, we have the summation of x equals 1 to infinity of x factorial over x squared. So we want to find the radius of convergence, we need to use the ratio test. So first we're going to take the limit of a sub n plus 1. So we make sure every x plus 1. So x plus 1 factorial over x plus 1 squared times the reciprocal of the original function, which is x squared over x factorial. After some multiplying out, we simplify it down to x squared over x plus 1, since the factorials cancel out. So this then, once you divide every single term by x, the highest term in the denominator, we get 1 over 1 plus 1 over x, which once you plug in the infinity gives you 1. When you have 1, the test cannot be determined and convergence is inconclusive. And that is the answer.